Figure 19.2, using arrays.java. In this example, we're actually going to introduce some built-in capabilities for manipulating traditional arrays in the Java programming language. In the java.util package is a class called arrays that contains a bunch of static methods for doing common manipulations on array data structures. So before we even look at this example, I'd like to take a quick look in the online documentation at the arrays class, which again is in the java.util package. And when I pull up the arrays class and show you its method summary, you'll notice that all of the methods start with the keyword static, indicating that you can invoke these methods via the name of the class called arrays and then the name of the method. Now, there are some interesting capabilities in here. The first method here, asList, is a way for you to take an array and give it back to the program to be viewed as a list data structure, and that can be handy for a number of reasons, not the least of which is using an array to initialize another collection of data. Also, you'll notice that there's many overloaded versions of the binary search function for various different primitive type arrays, and as I scroll down you'll see towards the bottom here that we also have generic versions that allow you to handle any type of array, not just primitive types. So when you see T and a set of square brackets here, that's an indication that this is a generic implementation of the binary search method and that it can receive an array of any type as its argument. And there are a couple of other things to point out here, which are the fact that each of these two functions receives as its last argument something of type comparator. It's possible that whatever type we are trying to search through is a type for which we never really meant the objects to be compared, and therefore we can't really search through them without first defining how to compare objects of that type. And it turns out that you can implement an object that implements the comparator interface, and by doing so you can specify how to compare objects of your type for the purpose of a binary search, for example, or even for the purpose of sorting objects as well. In fact, we will demonstrate how to use a comparator for sorting in a subsequent example shortly. You'll also see that there's other methods here like copy of that enable you to make a copy of an existing array. You can copy a range of elements from an existing array. You have this function here called deep equals, which is it says it returns true if two arrays are deeply equal to one another, which would basically mean not only that they have the same objects, but that the objects themselves have the same data within them as well. Scrolling down here, you can see lots of different overloaded versions of the equals method for comparing two arrays, including a version that takes two arrays of any type of object. And then scrolling down further, there's a fill method for arrays so that you can fill an array with a value or a set of values. We've got hash code methods for arrays where you can actually calculate a hash code for an entire array, and that would be if for any reason you happen to want to use an array as the key in a hash table like data structure. Also, we have sort methods, and we'll be taking a look at a couple of the sort methods. In particular, we're going to be looking at one of these sort methods that allows us to specify a comparator. And then also there is a toString method for each of the primitive type arrays and also for an array of objects that enables us to get a string representation of the contents of an array. So there's a number of built-in capabilities. In addition, if we go back to the java.lang package, there's one other feature I'd like to point out that we're going to be looking at in this example. The system class provides an array copy method, which you can see right here, that enables you to copy the contents of one array into another array. So there's lots of built-in array processing functionality. We happen to be focusing on a small subset of that in this example. So let's take a look at our using arrays example. At lines 7, 8, and 9 we declare some arrays and in a couple of cases initialize those arrays. So for example, we have the int array of type int declared and initialized at line 7. The initializer list has the numbers from 1 through 6 in it. We have a double array called double array initialized with some floating point numbers that are not in sorted order, and we'll be sorting that later on. We also have two arrays that we've declared but not created or initialized yet, one called filled int array and one called int array copy. Now before we get into the rest of the code here, let's scroll down to our main method and take a look at the main method, and we'll follow the flow of execution through the program by looking at what main says to do and then going to the appropriate methods. So we start by creating an object of our class using arrays, and when we create the new object, of course, we're going to execute the constructor. So let's take a look at the constructor. At line 12, you see the beginning of our constructor definition, and you'll see here that we've created the filled int array as a new array of integers with 10 elements, and we've created int array copy as a new integer array that has the same number of elements as the int array that was declared back here at line 7. So int array.length tells me how many elements are in that array, and as you can see, there are 6 elements in that array. At line 17, we then demonstrate the fill algorithm. We're going to, in this case, fill the filled int array with the value 7, and that's going to, of course, place 7 into all of the elements in the array. And we're also going to demonstrate the static sort method for the double array. We're going to sort out those elements into ascending order by default. And then finally, in the constructor here, we're going to use the system class's array copy method to copy elements from int array starting from location 0 in that array into int array copy starting at location 0 in that array, and the number of elements we want to copy is int array.length. That is the total of 6 elements. Right, so that's going to set up a couple of the arrays and also execute a couple of the algorithms that are built into the arrays class. Let's go back down to main to see what we do next. So next thing we want to do is invoke our print arrays method. So let's take a look at our print arrays method. And we're simply going to iterate through all of the different arrays in this example and output their contents. So for our double array here, we're going to grab one double at a time and output it with a single digit to the right of its decimal point. For our int array and for the filled int array and int array copy, in each case we're going to walk through the array and output its values separated by spaces, and at the very end we'll output a new line character using println, which in effect outputs 2 new line characters. Now I'm going to stop there for a moment and run the program so we can look at the output so far, and you can see that our double array is in sorted order. You can see that int array contains the numbers from 1 through 6 that it was initialized with. You can see that filled int array was filled with 7s by the fill algorithm, and you can see that int array copy indeed contains a copy of what was in the int array array. All right, so continuing on in main, we then call our print equality method. So let's take a look at print equality. In print equality, we wanted to demonstrate the arrays.equals method, and the way this method works is it compares two arrays that you specify to see if they have equal contents, and for the comparison, what it's actually going to do is compare the values in these arrays, because we're talking about integer arrays, and if it finds that any pair of elements in the two arrays are not equal, then it's going to return false, otherwise it will return true, and we'll store the result in this Boolean variable. So then after performing the operation, we'll print out whether int array is equal to or not equal to int array copy. Now we know by looking at our output that int array and int array copy are equal right now, so we should expect to see the double equals string be inserted in this printf. And then separately, we know in this case at line 60 that int array and filled int array are not equal, so we do expect to get false back here and display the not equals string as part of this formatted output. So if you look at the 2 lines of output that were produced by that method, you can see that indeed int array was equal to int array copy, and int array was not equal to filled int array. All right, continuing on in main. at line 72, we call our own method called search for int. You give it a number that you want to search for, and it's going to perform a search. So we're going to look for the number 5 in this case. And if we find it, that will give us a location value greater than or equal to 0, and we'll show you where we found that value. Otherwise, we'll say that that value is not in int array. And then separately, we're going to do the same search again, but with a different value that we know is not in the array, and that will return to us a negative value. So let's take a look at the search for int method. And in each case, all it's going to do is return the result of performing a binary search. Now, binary search requires that the array be sorted in the first place, and we happen to be working with int array, which was initialized with values in ascending order. So we're going to perform a binary search on the int array looking for the value that this search for int method receives. And a binary search returns either the index at which it finds the search key, the value that we're looking for, or it returns -1 if it can't find that value. And you can see down at the bottom of our output here that we did indeed find the value 5 located at element number 4 of the array, and we did not find the value 8763.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.